Okay, this is number 11. Here we have a parallelogram, and we're given some information. The first thing to note is this AC is not really referring to this top segment of the parallelogram. It's referring to the diagonal. That's where A is down here and C is over here. So the first thing is that we know the diagonals of a parallelogram bisect each other. So this segment will be congruent to this segment. So we can set up an equation there that 4x minus 2y will equal 3x plus 2y. And then we know the total length of the diagonal up here is 5x plus 4. And so the sum of the two pieces will add up to that diagonal. So that's the other piece of information we can, the other equation we can create here. So 4x minus 2y is one half of the diagonal. The other one is 3x plus 2y. And we know that in total that equals 5x plus 4. And this would be the system we need to solve. This one will actually turn out to be somewhat easy because in this equation right here, the y's are going to cancel. So if we simplify this system here, if we have 4x and on this side 3x, so we subtract 3x from both sides here, and we'll add 2y to both sides here. That will turn into x equals, these will cancel out, these cancel out, x equals 4y. And then if we simplify the bottom system, 7x, so we get 4x plus 3x is 7x, negative 2y plus 2y, those will cancel out to be 0, and then equals 5x plus 4. If we keep simplifying, x equals 4y. This bottom one turns into 2x equals 4. So that's not even really a system there. So it's a 4, not a y. We can just solve that directly to get x equals 2. So that's one piece of the equation. And then from here we know that x equals 4y. So 2 equals 4y. Y equals 1/2. And actually we don't even need to find y in this problem. It's not asking for that. It's only asking for the value of x. So we could have stopped right there. So here I've drawn a trapezoid, and just again, to make sure you draw these diagrams appropriately, when we see A, B, C, D, we have to make sure that when we go around the trapezoid, it's in that order. So we have A, B, C, D. And then I chose AB to be the bottom and CD to be the top because we're given this condition that AB is parallel to CD. So we know that that happens in a trapezoid. So let's review these options here. Angle A and D are complementary, which means they would add to 90. Well, that one's not true. A and D are supplementary. Well, let's see what happens there. If I draw in these full lines here, we have two parallel lines cut by transversal, which includes AD. So we know that this angle and this angle are supplementary because same side interior angles of cut by transversal are going to be supplementary. And so we could stop there. Let's maybe look at the other ones though. Angle A congruent to angle D, well, that's clearly not true. AC is congruent to BD, so AC is one diagonal, BD is another diagonal. In general, with a trapezoid, the diagonals will only be congruent if it's isosceles, but we're not told that it's isosceles, so it's not that. And then AB is this segment here, and BD, which is one of the diagonals, bisect each other. Well, clearly they don't bisect each other at all. They're meeting at an endpoint, so that's kind of a very obvious one. That's not true. So the answer here is B. So 13, we have another parallelogram. If CH equals 2x plus 1, so CH is 1/2 of this diagonal. HE is the other half of that diagonal. Again, diagonals bisect each other in a parallelogram, so we just can set those two segment lengths equal. 2x plus 1 equals 3x minus 4. Solve the system quickly here, or this equation simply. We subtract 2x from both sides, and we'll add 4 to both sides. 5 equals x, which means CE would equal 10, because that's the entire diagonal, so it's just 5 times 2, because it's a bisected diagonal. Part B has to do with angles here, so let's take a look. Measure of angle CDF. CDF, that's this angle here. And the measure of angle DFE. DFE is this angle here. And we're given those angles. Well, we know that those angles are congruent because those are alternate interior angles. Again, these are parallel lines bisected or cut by a transversal. Those alternate interior angles are congruent, so we can just go ahead and set this angle equal to this angle. So we get 3x plus 2 equals 4x minus 2. Gotta distribute here. 3x plus 6, distribute again here. 4x minus 8. And then subtract 3x from both sides to get 6 equals x plus 8. Or x minus 8, sorry. And then we'll add 8 to both sides to get x equals 14. So we know x equals 14, and then we just plug that in to one of those formulas for CDF, or the expression given. So 3 times 14 plus 2 is 3 times 16, which equals 48. So that angle is 48 degrees, and so is the other one, because they are congruent. In a parallelogram, we know that adjacent angles are always supplementary, so this one's a pretty straightforward problem. We know that angle W plus angle Z has to be 180 for that reason. So we know x plus 2x minus 45 equals 180. 3x equals 180 plus 45. 3x equals 225. X equals 75 degrees, which is what's being asked for here. So here we're giving a quadrilateral figure, and we're given that this piece of this part of the triangle DC is 6, and we're given that AE is 3x plus 4, and BD is 2x plus 7. Okay, first thing is, maybe let's find what x is, because we're going to need to have that side. So because this is a parallelogram, opposite sides are congruent. Maybe we know it's a parallelogram because AB is parallel to ED, AE is parallel to BD, so we know that BD here is congruent to AE. And so we just set those two sides equal. 3x plus 4 equals 2x plus 7. Subtract 2x from both sides. Subtract 4 from both sides. And we get x equals 3. If we plug that in to this expression, 3x plus 4 to get AE, we'll get that the side length there is 13. So we know that that side is 13. But see how all three of these are congruent. So this is also 13, this is also 13, and we're asked for the perimeter of, let's just say, a triangle sign, triangle BDC. So to get the perimeter, we just add up the three sides. 13 plus 6 equals 32. Here we have a rhombus, and the definition of a rhombus is 4 congruent sides, which are marked here. So we do know that all these are 8. We are asked to find HM, which is this diagonal of the rhombus. Now this diagram gives angle HRM as 60 degrees, which is actually different from this angle. This is angle RHM. So RHM is this angle here. So that's 60 degrees. And because the sum of the angles in a triangle add to 180, we know this is also 60. And now that we have an angle, we can tell, because all the angles are 60, that this is going to be an equilateral triangle, so that's going to be congruent, which is also 8. So that diagonal of the rhombus is 8. So the proof of this is actually given in the answer key, but I just wrote it out in a more familiar form for you here. The way to really prove this is there's different strategies, but if you could prove that opposite sides are congruent, that would work to prove it's a parallelogram. So if you could prove this is congruent to this and this is congruent to this. Another approach could be to prove that AD is parallel to BC and DC is parallel to AB. That would give you a parallelogram. Or the strategy that's used here is if just working on two sides, or one pair of opposite sides, if you can prove that one pair of opposite sides is both congruent and parallel, then it's a parallelogram, and that's the strategy used here. So the way to get to that is we know that angle 1 and angle 2 are congruent because that's given. That this diagonal is bisected, so it's AP equals PC. And then we're trying to see if we can prove these top two lines parallel and congruent. So the first one, parallel, is actually already pretty easy. I'm just going to walk through the piece here. If we have angle 1 is congruent to angle 2, we know from that AD is going to be parallel to BC because alternate interior angles are equal. That means the line is parallel. So that's one piece of it. And then to prove that these are congruent, we're going to use the idea of congruent triangles. We have two pieces of information. We know that we have one side congruent to one angle congruent, so we need to find either another angle, or actually in this case we need another angle. And so angle 3 and 4 are congruent just because of vertical angles. If we do that, then we see that this top triangle, A or PAD, is congruent to PCB, and therefore congruent triangles have corresponding congruent parts. We know that this is congruent to this, and then we have that's our information that we needed. We proved those two segments, the opposing segments, both parallel and congruent, and so therefore we have a parallelogram. I'm not sure if you covered this, but I'll go ahead and do the review problem anyway. This is a mid-segment type problem for a trapezoid, and the gist of it is that we know that because this is congruent to this and this is congruent to this, that this segment of the trapezoid basically is the average of the two bases. And so basically x plus 35 is going to be halfway in between 4x plus 10 and 20. So it's kind of like the area formula for a trapezoid too. You take the average of the bases. Well, that number here, this mid-segment, is actually the average of the bases. And so the way we'll solve this is that we know the mid-segment of the trapezoid is going to be the average of each base. So we have the bottom base is 20. We're going to just add those two things up and divide them by 2. And solving this expression will get us the value of x. So I'm going to multiply both sides by 2 here. And then I'll distribute at the same time. So 2x plus 70. These 2's cancel. 20 plus 10 is 30 plus 4x. Subtract 30 from both sides. Subtract 2x from both sides. That gives us 40 on this side, 2x on this side. Divide both sides by 2 to get x equals 20. Well, here sometimes we can just, for trapezoid diagonals bisect, sometimes it's helpful just to draw kind of a random trapezoid and see what it looks like. You know, this one it's pretty clear that they don't bisect. So if we drew an isosceles trapezoid, you know, here it's pretty clear they don't bisect each other. Really, diagonals only bisect each other in parallelograms. So, since I suppose the strict definition of a parallelogram could be a trapezoid. Like, you know, this, if a trapezoid is just two opposite sides that are parallel, you know, someone could argue that that's a trapezoid, even though these other ones are also parallel. But I think when most people use trapezoid, they mean only one pair of opposite sides parallel. So we wouldn't really call that a trapezoid. And so for that reason, we're going to go ahead and choose never for this one. This one we have an isosceles trapezoid with these 4 pieces of diagonals given. The key fact here is an isosceles trapezoid. We know that that segment is congruent to that segment, so AE is congruent to EB, and we know that DE is congruent to EC. And so you can just use that fact to solve this problem. That's one way to do it. So if we have ED is equal to, if we start with DE is equal to EC, we know that 2x minus 3 equals x plus 8, and that would give us x equals 11. And then if we can do the same thing for the other sets of diagonals, or other pieces of diagonals, we know that AE, this one here, is going to equal BE. So that gives us 2x plus 5 equals 3x minus 6. Now this is just going to help us solve for x again. We don't really need to do it because we already know it, but this would be a good check. I subtract 2x from both sides, add 6 to both sides, we're going to get 11 equals x. And now we're asked to find DB, which is the entire diagonal, so we just need to add those pieces. So DE is 2x minus 3. That's going to be 2 times 11 minus 3 is 22, minus 3 is 19. That's DE. BE is going to be 3x minus 6. 3 times 11 minus 6 is 33. Minus 6 is 27. We add those two pieces together to get 46. So we know this is a rhombus. So angle 5 is one of the where the diagonals intersect. Well, we know that diagonals of a rhombus intersect at right angles. So that's a right angle there. That's definitely going to be true. Is angle 2 congruent to angle 3? Well, we know the diagonals bisect each other, so we know that those two would be congruent, as well as these 3 congruent. So we have a bunch of congruent triangles here. So essentially this triangle this triangle here, RH, whatever that center point is, and this triangle here are congruent. So angle 2 and angle 3 are corresponding angles and congruent triangles. And so that's true. The reason we know these are congruent is because of side, side, side. We have 3 sides that are equal in all these triangles. Angle 2 congruent to angle 4. Same reason, corresponding parts of congruent triangles. And then measure of angle 5, which is this 90-degree angle, is greater than angle 4. Well, we know that has to be true because the 2 other angles in a right triangle are each less than 90. Also true. And then if we have one true here, obviously E cannot be the answer. Well, this is a pretty straightforward coordinate geometry problem. To find a midpoint, we just need to know the 2 endpoints, which we don't know yet here, but these are pretty easy to figure out. So point C here, the x-coordinate is the same as B because it's a rectangle, so we know that's point 10, and it's at the x-axis, so the y value is 0, and then the coordinate, that's point C, and then coordinate A is going to be 0 on the x-axis, and then its y value is 6. Since we know these 2 points here, the midpoint, I mean, I suppose you could remember the formula, but I always just like to think of it that it's the average of the coordinates halfway on each piece. And so that's what's going on here. Halfway between 0 and 10 is 5, and halfway between this 0 and 6 is 3. So the midpoint is going to be 5, 3. I've gone ahead and written the midpoint formula here too, in case that's something you're more comfortable with. And it's x1 plus x2 over 2, y1 plus y2 over 2, and then just plug in the coordinates. For x1 was 0, 6, so this was x1 here. This is x1, y1, and this point would have been x2, y2. Well, this is an isosceles trapezoid. So before I even think about this, it looks like it's going to ask me about the angles here for this question, so I'm just going to go ahead and write in everything we know about the angles. Since it's an isosceles trapezoid, we know that angle is also going to be 60. And then same side adjacent angles on a trapezoid are supplementary. So this angle is going to be 120 degrees, as is this angle. So now we have all the information to evaluate these statements. So BIR is this angle right here. We know it's 120. So BIR equals which of the following? The measure of DBI. DBI is also 120, so that's true. 2 times the measure of DBI. DBI is 120. 2 times DBI is 240, so that's one's not true. And then 180 minus IRD. So IRD is 60. 180 minus 60 is 120, which is the same as angle BIR. So the answer is 1 and 3. Okay, so we're giving a quadrilateral here, and we know the diagonals are perpendicular, and at least one of the diagonals is bisected by these marks right here. So from right there, from congruent triangles, we have this triangle here is congruent to this triangle here because of side, angle, and they share a common side. We know for sure that this side has to be 12. So we know A is the right answer, is at least one right answer. So another question might be, boy, it sure looks like DG could also be 12, so why isn't it answer B or answer B also? Well, when we look at this side of the triangle, you know, we can say, we know that this triangle DGD center point and CG center point F are congruent because they share this common side, they have a right angle, and then they share this, they have this congruent side and they share this common one. So we definitely know that GD is congruent to FG, but that doesn't really tell us anything that it's congruent to 12. And so therefore we're not able to determine that it's 12. And if I redraw this one a little differently, so I've redrawn it here, it will make it more clear why this can't be true. So I've just redrawn another possible version of this diagram that still meets all the criteria. So DE is still 12. And again, we know that EF has to be 12 because congruent triangles. But if I took G and stretched it out, that would still satisfy this problem because there'd still be a right angle here. This would still be 12. And so this hopefully makes it more apparent why GD doesn't necessarily need to be 12. And then DF, well, it can't be 24 because each one of these pieces is a leg of a right triangle where the hypotenuse is 12. So we know that this DF has to actually be less than 24 because each leg has to be less than 12. So it's not that one. And we did find length A. So that's why we eliminate D. So the answer here is A.